Settle in now and let your body grow heavy, soft, and still. There is nothing else you need to do, nowhere else you need to be. Just allow yourself to rest here in this quiet space. Let your breath be easy, a gentle tide rising and falling without any effort. As you breathe, let your mind drift. We are going on a journey tonight, a quiet and immense journey, following a path that is both ancient and new. Have you ever held a glass of water cool against your hand and wondered about its story? Have you ever looked up at a soft, white cloud and considered where it began? Tonight, we will follow just one piece of that story. We will follow a single, tiny molecule of water on its vast, cyclical journey through the world. You don't need to hold on to any thoughts. Just allow the story to wash over you, as gentle as a slow-moving stream. If you fall asleep, that is perfectly all right. This story will be here, flowing onward, waiting for you whenever you choose to listen again. So, close your eyes if you feel comfortable. Let go of the day, and let us begin. Our journey starts in a place of profound quiet and stillness. A place of deep, deep darkness, far from the sun, far from the wind, far from the noise of the world. We begin in the heart of the great, deep ocean. Imagine, if you will, our molecule. It is a simple, elegant thing. One atom of oxygen and two smaller atoms of hydrogen bonded together. The oxygen atom holds a slight negative charge, while the two hydrogen atoms, perched on one side, hold a slight positive charge. This makes our molecule polar, like a tiny, weak magnet. It has a positive side and a negative side. This simple fact is the secret to almost everything that will happen on its journey. Here, in the deep ocean, our molecule is not alone. It is surrounded, embraced on all sides, by countless trillions of other water molecules. It is part of a vast, silent community. The positive side of one molecule feels a gentle attraction to the negative side of its neighbor. This fleeting connection is called a hydrogen bond. For a tiny fraction of a second, our molecule holds hands with another. And then the bond breaks, and it forms a new one with a different neighbor. This happens over and over, billions of times a second. A constant, silent, flickering dance of connection and release. It is this dance that gives water its substance, its liquidity. It is what allows the molecules to flow and tumble past one another, always connected, yet always free to move. Here, in the abyss, the pressure is immense. Imagine the weight of miles of water pressing down from above. This pressure is not a crushing force for our molecule. It is a constant, steady embrace. It holds the community of molecules tightly together, making the water dense and heavy. The temperature is just a few degrees above freezing. The cold slows everything down. The dance of hydrogen bonds is a little less frantic here. The molecules move with a slow, heavy grace. There is no light. The sun is a distant memory, its rays unable to pierce this profound depth. The only light that ever appears is the soft, ghostly glow of bioluminescence from a passing creature of the deep. A fleeting pulse of pale blue or green light that drifts by like a dream, illuminating nothing, and then is gone, leaving the perfect darkness as it was before. Our molecule drifts. It is part of a deep, slow current, a river within the ocean that moves at a pace almost too slow to perceive. It may move only a few inches in a day, a few miles in a year. Down here, time has a different meaning. Decades, centuries can pass like a single long, drawn-out breath. There is no sense of hurry. There is only the slow, patient drift. The water here is salty. Other molecules and ions are dissolved in this vast liquid universe. Sodium, chloride, magnesium, they drift among the water molecules, occasionally bumping into our molecule, but they're just fellow travelers in the slow, dark current. Our molecule feels the gentle, rhythmic vibration of its own atoms. The hydrogen and oxygen atoms are not static. They're constantly trembling, a tiny, internal hum of energy. This is the essence of its temperature, its inner life. As it drifts, it is part of a colossal, planet-spanning system called the thermohaline circulation. a global conveyor belt. The water here is cold and salty, which makes it very dense. This density causes it to sink in the polar regions and begin this long, slow journey along the ocean floor. Our molecule began its descent centuries ago, perhaps in the frigid waters of the North Atlantic or the icy seas around Antarctica. It has been traveling in this deep, quiet world for a very, very long time. It has drifted over vast abyssal plains, flat and featureless expanses of sediment that stretch for thousands of miles. It has been guided by enormous, sloping ridges on the seafloor, the mid-ocean ridges where new crust is born. It has flowed through deep submarine canyons, carved by ancient underwater landslides. But from the perspective of our molecule, it is all just a slow, unchanging, peaceful drift. The pressure is a constant hug. The darkness is a soft blanket. The cold is a deep stillness. The company of its fellow water molecules is a steady, silent presence. There's a profound sense of peace in this state of being. No goals, no destinations. Just being, just drifting, a part of something immense, ancient, and eternal. Let your own body feel this sense of deep, quiet stillness. The feeling of being held and supported. The feeling of time slowing down, stretching out into a long, peaceful moment. For now, this is the entire universe. This dark, quiet, slow-moving river at the bottom of the world. The gentle, constant flicker of bonds forming and breaking. The silent hum of existence. Nothing to do, nowhere to go. Just the peaceful, patient drift. And so it continues for an impossibly long time. Generations of life pass on the surface world. Empires rise and fall, forests grow and recede. But down here, the journey is only just beginning. The current carries our molecule eastward, part of a slow-moving tongue of Antarctic bottom water. It creeps along the floor of the Southern Ocean, a journey that will take hundreds of years. The path is not straight. It is deflected by the rotation of the Earth, the Coriolis effect, which imparts a slow, gentle curve to its motion. It winds around undersea mountains called seamounts, which rise from the abyss like forgotten monuments. In the darkness, strange forms of life exist, adapted to this world of pressure and cold. Tube worms cluster around hydrothermal vents, where superheated, mineral-rich water billows out from the Earth's crust. Our molecule may drift past one of these oases of life, feeling a sudden, localized warmth and the presence of strange chemicals like hydrogen sulfide. It is a brief and alien encounter in the vast, cold darkness, a reminder that even here, life finds a way. But our molecule is swept onward by the current, leaving the vent behind, returning to the familiar cold and quiet. The journey continues northward into the vast expanse of the Pacific Ocean. The current weakens, spreads out, and begins, ever so slowly, to mix with the water layers above it. A subtle change begins to occur, a gradual lessening of the immense pressure, a fractional increase in temperature, perhaps by 1 degree over a century. These changes are imperceptible on a human timescale, but for our molecule, they mark a new chapter in its long journey. It is beginning to rise. This ascent is even slower than the journey across the ocean floor. It is a process of gradual mixing, of diffusion. Our molecule is stirred upward by the slow, chaotic churn of the ocean's interior. It rises meter by meter, year by year. As it rises, the world around it begins to change. After centuries of absolute blackness, a hint of light begins to appear. It is not light as we know it on the surface. It is a deep, faint spectral blue, the last surviving wavelength of sunlight that has managed to penetrate the upper layers of the ocean. This is the twilight zone, or the mesopelagic zone. The pressure is still enormous, but less than in the abyss. The water is still cold, but not freezing. And there is this faint, constant glow, a perpetual twilight. Here, life is more abundant. Strange fish with enormous eyes, designed to capture every last photon of light, drift by. Gelatinous creatures, like siphonophores and jellyfish, float like living chandeliers, some of them producing their own soft, rhythmic pulses of light. Our molecule might drift past a school of lanternfish, their bodies adorned with tiny lights, like a constellation of stars moving through the deep. The ascent continues. Slowly, over more decades, our molecule is carried higher. The blue light becomes stronger, more defined. The temperature continues to rise, degree by gentle degree. The dance of the hydrogen bonds becomes a little more energetic. The molecules tumble and flow with a bit more freedom. Other molecules, which were scarce in the deep, become more common. Dissolved oxygen, produced by phytoplankton in the sunlit waters far above, is more plentiful here. The world is becoming more complex, more active. Eventually, our molecule rises into the top few hundred feet of the ocean. The sunlit zone, the epipelagic zone. And here, everything changes. The world is flooded with light. Bright shafts of sunlight pierce the water, scattering and shimmering, creating a dazzling, ever-shifting pattern of light and shadow. The water is warm, heated by the sun's energy. Our molecule, so long accustomed to the cold, now vibrates with this new warmth. Its internal hum is faster, more energetic. The dance with its neighbors is lively and fast. Hydrogen bonds form and break in a dizzying, joyful frenzy. The surface is just above. Our molecule can feel the motion of the world above it, the rhythmic lift and fall of the waves, the surge and sway of the surface currents. The world is no longer silent. It is filled with sound. The muffled rush of wind over water, the distant calls of marine mammals, the crackle and pop of tiny crustaceans. Life here is vibrant and abundant. Our molecule drifts through vast balloons of phytoplankton, microscopic green organisms that float in the water like dust motes in a sunbeam. They are the foundation of the ocean's food web, turning sunlight into energy. Our molecule may drift right beside one of these tiny life forms, a silent witness to the miracle of photosynthesis. It is part of a great, swirling gyre, a massive, circular current that dominates the ocean basin. It spins in a slow, majestic vortex, driven by the winds and the Earth's rotation. For years, or even decades, our molecule may circle in this gyre, tracing a vast loop across the Pacific. It is a time of activity, of warmth, of light. It is the complete opposite of the deep, dark, quiet abyss. But this is not the end of the journey. It is merely another stage. Our molecule finds itself on a calm, hot day, right at the very surface of the ocean, the boundary between the water and the air. Here, it experiences a phenomenon called surface tension. The water molecules at the surface have no other water molecules above them, so they hold on to their neighbors beside and below them a little more tightly. They form a kind of skin on the water. Our molecule is part of this skin, bobbing at the very top of the world. It feels the direct heat of the sun. Photons, tiny packets of energy from the sun, stream down and strike the water. They are absorbed by the molecules, transferring their energy. Our molecule absorbs a photon, and then another. Its internal vibration becomes more and more intense. It is jiggling and trembling with excess energy. All around it, its neighbors are doing the same. They are jostling and bumping against each other, energized by the sun's relentless warmth. The hydrogen bonds that hold them together are being stretched to their limit. And then it happens. Our molecule has absorbed just enough energy. Its vibration becomes so intense that it breaks free from the hydrogen bonds that hold it to its neighbors. It snaps the gentle, sticky connections that have defined its existence as a liquid, and it lifts. It rises from the surface of the ocean. It is a moment of profound change. For the first time in perhaps 1,000 years, our molecule is alone. It is no longer part of the vast, liquid community. It has undergone a phase change. It has evaporated. It is now a molecule of water vapor, an invisible gas floating in the air. The feeling is one of incredible lightness. The immense, warm, blue ocean shrinks below it. The feeling of pressure is gone. replaced by a sense of boundless space. It is lifted by a rising current of warm air, a thermal. It floats upward, a single, invisible speck in the vastness of the sky. Around it are other water vapor molecules that have also made this journey, but they are spaced far apart. They no longer cling to each other. They are free agents drifting on the breeze. It has left the world of liquid and entered the world of gas. The journey continues upward and upward. As it rises, the air grows colder. The warmth of the sun-drenched surface is left far below. The pressure of the atmosphere lessens. Our molecule is carried by winds, vast rivers of air that flow around the planet. It may travel for hundreds or even thousands of miles in this gaseous state. It drifts over the ocean, a silent, invisible passenger on the wind. As it drifts higher and higher, the cold intensifies. The molecule itself slows down. Its energetic vibration, which allowed it to escape the ocean, begins to subside. The cold air is stealing its energy. It moves more and more slowly, and as it slows down, it becomes susceptible once again to the familiar pull of its own nature. The slight positive charge on its hydrogen atoms and the slight negative charge on its oxygen atom begin to look for partners. At this altitude, the air is not empty. It is filled with microscopic particles. A tiny speck of dust, a grain of pollen, a crystal of salt thrown up from the sea spray. These are called condensation nuclei. Our molecule, now moving slowly enough, bumps into one of these particles, a minuscule fleck of dust, and it sticks. The particle surface gives it something to hold on to. A moment later, another slow-moving water vapor molecule bumps into it and sticks as well. Then another and another. A community is beginning to form again. This process is called condensation. The molecules are changing from a gas back into a liquid. They are huddling together for warmth, drawn by their innate polarity, clinging to the dust particle like a life raft. Billions of molecules join the gathering. What was once a collection of single, invisible gas molecules is now a single, microscopic droplet of liquid water. Our molecule is now part of this tiny droplet. It is once again surrounded by its own kind, feeling the familiar, fleeting embrace of hydrogen bonds. This droplet is still microscopic, far too small to be seen, but it is not alone. All around it, for miles and miles, the same process is happening. Trillions of other microscopic droplets are forming, each one centered around a speck of dust or salt. And these droplets are all floating together in the cold air. This vast, visible collection of tiny water droplets is a cloud. Our molecule has become part of cloud. From the ground, a cloud looks like a soft, solid object, like a scoop of cotton. But from within, as our molecule experiences it, a cloud is a vast, diffuse space. It is mostly empty air, filled with these tiny, floating droplets. The droplets are so light that the upward pressure of the air currents keeps them suspended. They are in a state of constant, gentle motion, a slow-motion dance in the sky. Our molecule, within its droplet, drifts with the cloud. The cloud is carried by the wind, journeying across the sky. It may be a low, puffy, cumulus cloud drifting through a warm, blue sky, or it may be part of a high, wispy cirrus cloud made not of liquid water droplets, but of tiny ice crystals, as the temperature is well below freezing. If it were a cirrus cloud, our molecule would find itself locked into a solid hexagonal lattice. But for now, let's imagine it is in a cumulus cloud, a droplet of liquid water. Inside the cloud, the droplet is not static. It is constantly changing. It collides with other droplets. Sometimes they bounce off each other, but sometimes they merge, a process called coalescence. Two tiny droplets become one, slightly larger droplet. This happens over and over. The droplet that contains our molecule bumps into another, and they combine. Now it is twice as large. It collates with another and another. It is growing. As it grows, it becomes heavier. The journey through the cloud can last for hours or for days. The cloud itself is a dynamic, living thing. It grows and shrinks, its edges dissolving back into invisible vapor, while its center grows thicker with new droplets forming. Our molecule is carried on updrafts to the top of the cloud, then sinks down into its depths. It is a slow, churning, tumbling journey within this city of water in the sky. The droplet containing our molecule continues to grow. It has now combined with millions of other droplets. It has become heavy. It is still small, just a fraction of a millimeter across, but it is now heavy enough that the upward air currents can no longer support it. The pull of gravity, a force that has been acting on it all along, finally wins. A new journey is about to begin. The droplet begins to fall. It slips out of the bottom of the cloud. Our molecule, as part of this droplet, is now a raindrop. The fall is not a terrifying plunge. It is a slow, gentle descent at first. As it falls, it continues to grow, sweeping up smaller cloud droplets in its path. It accelerates, reaching a constant speed, its terminal velocity, where the pull of gravity is balanced by the resistance of the air. The air rushes past, but feels like a soft, steady pressure from below. The world, which from the cloud was a distant, blurry patchwork, now grows larger and more detailed. The green of forests, the blue of lakes, the brown of the earth. Our molecule is returning to the surface of the planet. It is one of many trillions of molecules in this single raindrop, and the raindrop is one of billions falling from the cloud in a steady, soft rain. It is a great homecoming. The feeling is one of release, of return. The journey through the sky is over. The raindrop falls, a tiny, perfect sphere of water, a liquid jewel. Inside, our molecule is tumbling and turning, part of the liquid whole. The journey downward takes several minutes. It falls through layers of air, each with a different temperature and scent. It falls toward a vast, green expanse, a forest high in the mountains. The raindrop, with our molecule inside, is destined to land here. It does not crash. It lands with a soft tap on the broad, waxy surface of a leaf, a fern growing in the damp, shaded understory of the forest. For a moment, the raindrop holds its shape on the leaf, a perfect, shimmering dome. This is due to cohesion, the same force of hydrogen bonds that keeps the molecules clinging to each other, and adhesion, the force that makes the water stick to the surface of the leaf. Our molecule is now at rest, in a droplet, on a leaf, in a quiet, green world. The rain has stopped. The air is fresh and smells of damp earth, of pine needles, and of decaying leaves on the forest floor. The world is seen through the curved lens of the droplet, a distorted, beautiful miniature. Sunlight filters through the high canopy of the trees, and a single beam strikes the droplet, making it sparkle like a diamond. The droplet does not stay on the leaf for long. Some of it might evaporate, turning back into vapor. But this droplet begins to slide. It rolls to the edge of the fern frond, hangs there for a moment, and then drips off. It falls a short distance and lands on the soft, mossy ground. Here it soaks in. It disappears from sight, seeping into the dark, rich soil. Our molecule has entered another new world, a subterranean world. It percolates downward, pulled by gravity, through the spaces between particles of soil and sand. It trickles past grains of quartz, flecks of mica, and particles of clay. It mingles with the rich organic matter of the humus, the decomposed remains of plants and animals. This journey is slow and meandering. It is filtered and cleaned by the soil. And then it feels a new kind of pull. It is drawn towards a root hair, a tiny, fibrous extension of a great tree's root system. The tree is thirsty, and our molecule, along with its neighbors, is about to be drawn into the life of this tree. It passes through the cell wall of the root hair by a process called osmosis. It has moved from an area of high water concentration, the soil, to an area of lower water concentration, the inside of the root. It is now inside a living organism. The journey becomes a silent, steady, upward climb. Our molecule is drawn into a vessel called the xylem. The xylem is like a microscopic pipeline, a bundle of long, thin, dead cells that run from the roots, up the trunk and branches, all the way to the leaves. our molecule is pulled upward by an incredible silent force. This force is transpiration. High above, in the leaves of the tree, tiny pores called stomata are open to the air. Water is constantly evaporating from these pores. As one water molecule evaporates from a leaf, it pulls on the one behind it, thanks to the cohesive power of the hydrogen bonds. This pull is transmitted all the way down the chain of water molecules, a continuous column of water right down to the roots. Our molecule is part of this chain. It is being pulled upward against the force of gravity. It is a slow, steady, relentless elevator ride. It travels up the root into the massive trunk of the tree. Let's imagine this is an ancient redwood, hundreds of feet tall. The journey upward will take days or even weeks. It is a journey in darkness through the intricate plumbing of this giant living being. Our molecule travels through the sapwood, just beneath the bark. It can feel the slow, steady pulse of the tree's life. It is carrying vital nutrients, dissolved minerals that the tree has absorbed from the soil, upward to the leaves. It is the lifeblood of the tree. The column of water is incredibly strong. The hydrogen bonds that link the molecules together are so powerful that the column can withstand the immense tension of being pulled hundreds of feet into the air. Our molecule moves upward centimeter by centimeter, hour by hour. It passes growth rings that mark the passing of years, decades, centuries. It is traveling through living history. Finally, after its long, slow ascent, our molecule reaches its destination. It flows into the network of veins in a leaf, high up in the sunlit canopy. The leaf is a bustling factory. Photosynthesis is happening all around. Carbon dioxide is being taken from the air, and with the energy of sunlight, it is being converted into sugar, the food for the tree. Water is a key ingredient in this process, but our molecule is not destined to be broken apart for photosynthesis. Its journey has another purpose. It flows to the surface of a cell inside the leaf, near one of the tiny pores, the stoma. The sun is shining, the air is warm. The stoma is open, releasing oxygen and taking in carbon dioxide. And from the wet surface of the cell, our molecule feels that familiar surge of energy. A photon of sunlight gives it the kick it needs. The hydrogen bonds break one last time inside the tree, and our molecule evaporates. It leaves the leaf and drifts out of the stoma, back into the open air. This process is called transpiration. Our molecule is once again a single, invisible molecule of water vapor. It has been released from the tree, a gentle exhalation from the forest. It floats for a moment in the warm, sunlit air, surrounded by the scent of pine and chlorophyll. It has helped the tree to live, and in return, the tree has lifted it back into the sky. The journey is not over. It has just entered another new phase. The wind catches it, a steady, cool wind blowing from the west. Our molecule is carried eastward, away from the coastal forest, over mountain ranges. It rises again into the colder upper atmosphere. It is on a new path, heading towards a different fate. It drifts for days, part of a vast, invisible river of atmospheric moisture. It travels over plains and deserts, a high-altitude traveler. The air it is in becomes progressively colder and colder. It is passing over a high mountain range in winter. The temperature drops far below freezing. Once again, our molecule slows down. Its internal vibration becomes a gentle hum. It is ready to change phase again. But this time, it is so cold that it will not become a liquid. It will bypass the liquid state entirely. It finds a microscopic particle in the air. As it makes contact, it does not form a liquid droplet. Instead, it snaps instantly into a solid structure. This is called deposition. It has become a tiny crystal of ice. The geometry of the water molecule, the 1045-degree angle between the two hydrogen atoms, dictates the shape it will form. As other water vapor molecules arrive and deposit onto this seed crystal, they arrange themselves into a beautiful six-sided pattern, a hexagonal lattice. Our molecule has become part of a snowflake. The snowflake grows, becoming more and more intricate, a unique and symmetrical jewel. No two large snowflakes are ever exactly alike, because their individual journey through the cloud, the temperatures and humidity they encounter, shapes their growth in a unique way. Our molecule might be part of one of the 6 delicate arms, or at the very center of the intricate pattern. It is now locked in place, its hydrogen bonds forming a strong, rigid framework. It is no longer flowing or drifting. It is part of a solid, crystalline structure. The snowflake becomes heavy, and it begins to fall. It tumbles slowly, gracefully from the sky, along with millions of other snowflakes, a silent, white curtain descending upon the high peaks. It lands softly on the surface of a vast field of snow. It has come to rest on a glacier. This is the beginning of a long, long period of stillness. More snow falls. The layer containing our snowflake is buried. Days, weeks, years pass. The weight of the snow above increases, compressing the layers below. The delicate snowflakes are squeezed together. The air is forced out. The snow transforms into a granular ice called firn, and then, under even more pressure, it becomes dense, solid glacial ice. Our molecule is now trapped. It is part of a massive river of ice. It is still a water molecule, H2O, but its atoms are vibrating slowly in the deep cold, locked into the crystal lattice. Time slows down to a geological pace. The glacier moves, but so slowly it is imperceptible. It flows under its own immense weight, like an impossibly thick and slow river. It may move only a few feet in a year. Our molecule, buried deep within the ice, is carried along on this slow, grinding journey. Centuries pass. Millennia. From within the ice, the world is a translucent blue-white. The pressure is enormous. The cold is profound and constant. The glacier scours the mountain beneath it, grinding rock into fine powder, carving out valleys and shaping the landscape. Our molecule is a silent passenger in this immense engine of geological change. It is in a state of suspended animation, a long, deep, frozen sleep. It may remain in this glacier for 10,000 years, or even longer. It is a prisoner of the cold, but no state is permanent. The journey must continue. The glacier, over thousands of years, flows down from the high peaks into a lower, warmer valley. The climate of the planet itself may be changing, entering a warmer period. At the snout, or the terminus, of the glacier, the ice is melting. After its long, frozen slumber, our molecule is about to awaken. The ice that contains it reaches the edge. The warmth of the sun and the milder air begins to work on the crystal lattice. The vibrations of the atoms increase. The rigid hydrogen bonds begin to stretch and break. The ice melts. Our molecule is released from its crystalline prison. It is liquid again. It flows out from the base of the glacier in a trickle of meltwater. It joins other trickles, forming a stream. The water is numbingly cold and crystal clear. It is filled with dissolved oxygen, making it a vibrant habitat for life. Our molecule has been reborn into a new world. It is now part of a glacial river. The river is fast and energetic. It tumbles and rushes down the mountain valley it helped to carve. Our molecule is swept along in the turbulent flow. It cascades over waterfalls, swirls in eddies, and rushes through narrow gorges. It rolls over smooth, polished stones on the riverbed. The journey is quick and lively. As the river descends, it widens and slows. The water warms up under the sun. It flows out of the mountains and into a wide, flat plain. It meanders through green meadows dotted with wildflowers. The landscape it passes is gentle and pastoral. One sunny afternoon, the river flows through a quiet meadow. A deer, cautious and graceful, comes to the riverbank to drink. It lowers its head and laps at the cool, clear water. And in one of those laps, it drinks in our molecule. Once again, our molecule has entered a living being. But this time, it is a warm-blooded animal. It passes into the deer's stomach and is quickly absorbed into the bloodstream. The world becomes warm, dark, and rhythmic. Our molecule is now flowing through arteries and veins, propelled by the steady, powerful beat of the deer's heart. Water is essential for all life, and our molecule has a job to do. It is the solvent in which all the chemical reactions of life take place. It transports oxygen and nutrients to the cells. It helps to regulate the deer's body temperature. Our molecule is carried through the intricate network of capillaries, vessels so fine that blood cells must pass in single file. It may be delivered to a muscle cell, helping it to contract as the deer walks. It may travel to the brain, a part of the fluid that cushions and protects that vital organ. Let's imagine it flows into a lung cell. It is part of the essential fluid that keeps the tissues moist and healthy. The deer breathes. It takes in a deep breath of fresh, meadow air, and then it exhales. As it exhales, the warm, moist air from its lungs is released into the atmosphere. And on that breath, our molecule, having been on the surface of one of the lung cells, evaporates. It changes phase once again from a liquid to a gas. It leaves the deer's body and becomes a particle of water vapor, mingling with the scent of grass and the warmth of the animal's breath. This interlude within a living creature was brief, perhaps only a few hours, but it was a vital part of the cycle. The molecule has now been returned to the atmosphere, ready for its next journey. It drifts on the gentle breeze of the meadow. It is low to the ground this time. It doesn't rise into the high atmosphere. It is part of the humid air of a summer's day. It drifts over fields and farms. As evening approaches, the air cools. The ground, which was warmed by the sun, is now radiating its heat away. The air near the ground becomes cool and damp. Our molecule of water vapor slows down. It is ready to condense again. But this time, it doesn't form a cloud high in the sky. It condenses on a cold surface near the ground, a blade of grass. As the temperature drops to the dew point, our molecule, along with countless others, changes from invisible vapor to a liquid droplet on the cool surface of the grass. The sun rises the next morning on a world glittering with dew. Our molecule is part of one of these tiny, perfect droplets, catching the first rays of morning light. It has had a short, gentle journey through the air and a short, gentle rest. As the sun climbs higher, the air warms up. The dew begins to evaporate. Our molecule once again receives a burst of energy from a sunbeam, breaks its bonds with its neighbors in the dewdrop, and lifts back into the air as vapor. This time, a stronger wind catches it, a wind blowing steadily towards the coast. It joins a massive flow of humid air, moving from the land back towards the sea. It has been on land for a long time now. It has been inside a tree, locked in a glacier, flowing in a river, a passenger in a deer, and a jewel of dew on the grass. Now it is heading home. It flows in the air over coastal plains, over marshes and estuaries where fresh water from the rivers mixes with the salt water of the sea. It can smell the salt in the air. The invisible water vapor molecules that were once part of the ocean are all around it. And then it is over the ocean again, the vast blue, moving expanse that was its home for so long. The air over the ocean is turbulent. The water vapor might be swept up to form a cloud, to rain back down into the ocean. Or it might simply diffuse downward, mixing with the air right at the sea's surface. Let's imagine this latter path. Our molecule drifts downward, and its journey as a gas comes to an end as it makes contact with the water surface and is absorbed back into the liquid. It condenses. It is liquid water again. The feeling is a familiar one. The immediate, comforting embrace of other water molecules. The flicker of hydrogen bonds. The taste of salt. It is home. It has returned to the ocean. The journey has come full circle. It is now part of the surface layer of the sea, once more, bobbing in the sunlight, lifted and lowered by the gentle swell of the waves. It has traveled thousands of miles through air and earth and ice and life. It has been a gas, a liquid, and a solid. It has been part of a cloud, a river, a tree, a glacier, an animal. And now, it is back where it began, in the great Mother Ocean. But the cycle is never truly over. It is endless. Our molecule, now part of the ocean, begins its next chapter. It is caught in a current that pulls it away from the surface. a downwelling current. It begins to sink. Slowly, gently, it leaves the warm, sunlit world behind. The light fades from bright white to yellow to green, and then to a deep, deep blue. The water grows colder. The pressure begins to increase. It is sinking back into the twilight zone, and then deeper still into the abyss. It is beginning the long, slow journey all over again. The journey back into the dark, quiet, peaceful depths, where we'll drift for centuries before it sees the sun once more. As our molecule descends, let your own mind sink into a state of deep, quiet rest. Feel the gentle pull downward into a place of stillness and peace. The journey of this one molecule is the journey of all water. It is a story of connection, of transformation, and of endless renewal. It is a cycle that sustains all of life on our planet, and you are a part of that cycle. The water within your own body has been on a similar journey. It has been in oceans and clouds and rivers. It has been a part of plants and animals. It is an ancient traveler, and for a short time, it is a part of you. As you rest now, feel that connection to the great, flowing story of water. Let it soothe you. Let it carry you into a deep and peaceful sleep. There is nothing more to do now. Just rest. Just drift. The story goes on. The cycle continues forever and ever. Let it flow on without you for a while. Let yourself sink into the quiet, dark, peaceful abyss of sleep, drifting slowly, peacefully down into the calm. The pressure is a gentle, steady hug. The darkness, a soft blanket. The quiet, a profound peace. Down and down into the slow, timeless current at the bottom of the world. Just resting now. Just drifting. Sleep now. Sleep deep. The water cycle is a vast and intricate system, and our molecule's journey could have taken many other paths. Imagine if, instead of being drawn into a tree, it had percolated deeper into the earth. It could have seeped down through porous rock, traveling for meters, then miles underground. It would become part of an aquifer, a vast underground reservoir of water held in layers of sand and gravel. Here, in this subterranean world, the darkness is absolute. The movement is incredibly slow, perhaps only a few inches a year. It is a world of immense patience. Our molecule might remain in this aquifer for thousands of years, a hidden treasure beneath the surface. Eventually, it might emerge at a spring, bubbling up from the ground to start a new river. Or it might be drawn up through a well to be used by humans. It might have ended up in a cup of tea or watering a garden, before evaporating and rejoining the atmosphere. The journey through human civilization is another complex path. Our molecule could have rained upon a city. It might have flowed down a street, into a storm drain, and through a water treatment plant. Here, it would be filtered and cleaned, a man-made imitation of a natural cleaning process that happens in soil and wetlands. After being treated, it might flow from a tap to be used for drinking, cooking, or washing. It would then travel through another set of pipes to a wastewater treatment plant, where it would be cleaned once more before being returned to a river or the ocean. In this urban cycle, our molecule would witness a different kind of world, a world of concrete and steel, of pipes and pumps. But the fundamental nature of its journey would be the same, a cycle of use and renewal. Or what if, upon falling as rain, it had landed in a vast, shallow lake in a hot, dry climate? The sun would beat down relentlessly. Evaporation would be intense. As water molecules like ours escaped into the atmosphere, the substances dissolved in the lake, the salts and minerals, would be left behind. The lake would become saltier and saltier over time. Our molecule might have stayed for a season, part of this increasingly saline environment, before making its own escape into the dry air. It could have been carried by the wind for hundreds of miles over a parched desert, a single invisible particle of moisture in a vast, arid landscape. It might have been the only source of water for a tiny desert plant, adapted to capture every possible molecule of moisture from the air. Its journey, in this case, would have been one of scarcity and preciousness. Consider another possibility for its time in the sky. It could have been part of a great storm, A hurricane born over the warm tropical ocean. Our molecule would have been drawn up into the swirling vortex, a world of incredible energy and motion. It would have spiraled upward at high speed in the eye wall of the storm, condensing and releasing enormous amounts of latent heat, the very energy that fuels the hurricane. It would have been flung around in torrential rains and powerful winds, a participant in one of nature's most powerful events. This journey would not have been calm and gentle, but it would have been just as natural, just as much a part of the Earth system for moving heat and moisture around the globe. After being released from the storm, it would have found its way back to a state of calm, perhaps in a flooded wetland or back in the tranquil ocean. Each path, each possibility, reveals another facet of water's character. It is a creator of landscapes, carving canyons and building deltas. It is the cradle of life, the medium in which biology unfolds. It is a regulator of climate, storing and transporting heat across the planet. It is a symbol of purity, of cleansing, and of endless change. Our molecule, simple and small, is a part of all of this. Its identity is constant, H2O, but its context is always changing. It is a traveler, a shapeshifter, a participant. As we let our own thoughts drift, we can return to that place of deep, oceanic peace where we began. The journey we have followed is just one loop in an infinite spiral. Our molecule, now descending back into the depths, carries the memory of its travels. The memory of the sun's warmth, the memory of the cloud's embrace, the memory of the trees' silent pull, the memory of the glacier's cold sleep. These are not memories in a mind, but subtle changes in energy, in isotopic composition, in its relationship with the world. It rejoins the great, slow current of the deep. The darkness returns, the silence returns, the immense, steady pressure returns. It is a state of being that is akin to deep meditation, a letting go of all forms, a return to the source. The frantic dance of the sunlit surface gives way to the slow, graceful waltz of the abyss. The solitude of the vapor state gives way to the profound communion of the liquid state. The rigidity of the ice gives way to the fluid freedom of the water. Everything is a cycle. Everything returns. As you lie here, ready for sleep, you can feel this cyclical nature in your own breath. The gentle inhale, the soft exhale. A constant, rhythmic exchange with the world around you. With every breath out, you release water vapor into the air, molecules that were just a moment ago a part of you. They are now beginning their own journey. And with every breath in, you take in the air of the world with its own invisible cargo of moisture, which may have come from an ocean far away or a forest just outside your window. You are connected. You are part of this endless, beautiful flow. Allow your mind to become as fluid as water. Let go of any rigid thoughts, any sharp-edged worries. Let them dissolve. Let them flow away. Imagine your consciousness as a great, deep body of water, becoming still and clear. The surface may have ripples from the day that has passed, but deep down, there's only calm, only quiet. Let your attention sink below the surface, down into that place of perfect stillness within you. This is the place of rest. This is the place of renewal. The journey of our water molecule is a story of letting go. It let go of the ocean to become vapor. It let go of its gaseous freedom to become a droplet. It let go of the cloud to become rain. It let go again and again to continue its journey. And now you can let go too. Let go of the need to be awake. Let go of the day. Surrender to the gentle, downward pull of sleep. It is a safe and peaceful journey, a return to the quiet depths of your own being. The story continues, but you do not need to follow it. You can simply rest, knowing that the cycles of the world are turning, that the water is flowing, and that all is well. Drift now. Float. Sink gently into the deep, dark, peaceful ocean of sleep. Let the current of slumber carry you away. There is only peace here, only rest,